Hey guys, today we're going to be looking at a science concept generally, probably in the context of chemistry though. And it's a pretty broad concept, right? So I think it's good that it's covered in year 10 because it's definitely got a lot of application in year 11 and 12. That concept is, or that law is, it's the law of conservation of mass, right? Now, essentially it starts from the idea that in this entire universe, all the energy already exists. There's not going to be more energy that can be created or energy destroyed. What does that leave? It only leaves the opportunity of something being transformed, right? Of energy being transformed. That's really key. Definitionally, what we can say is that mass cannot be created or destroyed, only transformed. Now, where is this going to go in your answers? Probably at one of the first sentences, right? Thinking about good technique for short answer questions, you definitely want to have a definition or some sort of foundational sentence there. So I guess in the context of chemistry, what does that look like? During chemical reactions, atoms are not going to disappear, they're just going to rearrange, right? They're just going to rearrange. This is going to become handy in balancing equations. This is really important because if equations are unbalanced, then that will be suggesting that the law of conservation of mass doesn't hold. So we'll go over that in a moment. And mathematically, what does it mean? This is important for any sort of quantitative related questions. The mass of reactants is going to equal the mass of products, right? Cool. Okay, so this is a concept covered in year 11, and I think, look, it's really easy to understand and definitely relevant for year 10. The idea of open versus closed systems. You can tell what one of these is open and what one is closed, right? This one's obviously open because imagine an open container, and this one's a closed container where the particles must stay within. Now, I've got a question here. Does the conservation of mass not apply to open systems? The answer is no. It's a universal law. Yes, it's a universal law and it applies to everything, right? It applies to if it's open or closed, but we can't measure it in open systems. Why? Because gases may escape or certain things may escape. And now I'll clarify that with a question in one moment. We can actually measure or, witness the law of conservation of mass in a closed system, maybe by performing an experiment and measuring the weight of products and reactants. It would be impossible to sort of test or validate that law in an open system, but it doesn't mean it doesn't exist. It still holds universally. It's just that we can only measure it in closed systems. That's quite important. Now, balancing chemical equations. This is what I just said before. This unbalanced chemical equation here, we've got the formation of water, H2O, formed from hydrogen gas because it's H2 and oxygen gas. If I was better, what would you do? You'd have the states, right? G, and water vapor, gas. And we can pretend the states are in the bottom as well. Write your states, even though I didn't. Definitely write your states. Okay, cool. So because it's unbalanced, you see we've got, what have we got here? 2 oxygens on this side. 2 oxygens on this side. We've only got 1 oxygen, right? What's happened to the law of conservation of mass? It's been violated. So that's why we need to balance it. Just like I said, a definition should come at the front of your short answer. A balanced chemical equation is almost as important, right? So I've had to balance him, and I'll do a separate video on how to balance chemical equations and a lot of the tips and tricks, but this is how you do it. You just want to do sort of a checklist on one side of H's and oxygens and then sort of just balance it that way. But I'll provide another video on that. Anyway, we see that the atoms on the left side, the reactants are equal to the products. So that's kind of adhering to the law of conservation of mass. Okay, now we can go to some questions. Explain why a closed container is necessary when carrying out an experiment to demonstrate the law of conservation of mass. This is what I was sort of inferring before slightly. Now, explain the Nessa verb. We've got to be paying attention to the Nessa verb, right? In your head, that you want to think, if for chemistry, you're thinking, what's the Nessa verb? In this case, it's cause and effect. And then how many marks is it? This one doesn't have a marking guideline, but I would imagine it to be about a 2 or 3 marker. And then we're thinking about one of the 2 things I said. We're thinking about equations and definitions. This one's, there's no need for an equation. It doesn't give any hint that we need to, or that we should even think about writing one, because it's just, it's more of a written answer. Okay, but definitely definition. The law of conservation of mass states that mass cannot be created or destroyed, only transformed. So I'm thinking about in the context of reactions that produce a gas, right? Like combustion or just anything else, acid base or whatever. Because many reactions result in gas production, if a system was open, the gas would escape. Upon weighing the remaining products, it would appear that the mass of products is less than the mass of reactants, which violates the law, the conservation of mass, right? So we need a closed system is required to retain any possible gases that are produced. And so when we weigh them, it shows that the masses are conserved or equal, right? So always thinking about going back and trying to relate to the definition. It's really key. Now, question 9, this is more of a mathematical one. This isn't too difficult. As long as you can intuitively understand what's going on. The law of conservation of mass, as I said, mathematically, it's that the mass of reactants is equal to the mass of products, right? So we've got hydrogen gas reacts with oxygen gas to make 36 grams of water. Figure out how much oxygen must have been used by applying the law of conservation of mass. So in your answer, this is essentially a definition. See how fundamentally you should be starting with the sort of foundational, either a definition or a formula for the maths, for the quantitative side of things. That's really important. And then here's just algebra, right? This is the mass of reactants here, 4 plus x, and 36 is the mass of products given products and given one reactant, right? So in maths, you know that if we have one variable unknown, we just have to get everything else to the other side and get x by itself, and then you can simplify, and you get 32 grams of oxygen was used. Yeah, so that's kind of how you do those two questions. Now, those are some pretty common questions with how you sort of go over that. Now, a lot of kids will forget to balance chemical equations. That's really important. A lot of kids also think that the law doesn't apply to open systems. It's a universal law. It's just that we can't measure it with open systems because the gas might escape, and how can you measure the weight of something if it's gone into the atmosphere? So those are the two main things, but it's a very fundamental rule, right? And definitely something that it's going to be the foundational, going to be applied to a lot of your future questions, essentially. All right, so that's it for this video.